Hello and welcome to Mechanical Y. On August 21st, 2017, the United States shall experience a total solar eclipse. This is an event where the orbit of the Earth around the Sun and the Moon around the Earth are such that the Moon shall completely obscure the Sun. This is unlike most other solar eclipses where the Sun is only partially obscured, leaving a bright ring around the Moon. Nowadays, we consider a total solar eclipse a fantastic spectacle, but 100 years ago such an event had enormous scientific significance. At the time, brilliant physicist Albert Einstein was pursuing his theory on general relativity, which summarizes our latest understanding of the behavior of gravity. According to this theory, light can be bent as it passes through a gravitational field. This came under severe criticism at the time, and in order to prove his theory correct, light bending would have to be observed. But this is no trivial data point. It takes a tremendous gravitational field to bend light such that it can be observed by us. This is virtually impossible to do in the laboratory or even observe in nature, unless that is, you have a very big object creating a very big gravitational field. Enter our Sun. Physicists at the time reckoned that the largest object in our solar system may be just big enough to get the job done. They could try to observe light bending around the Sun itself. But it doesn't take a Nobel Prize winning physicist to know not to look at the Sun. Enter the total solar eclipse of 1914, visible in northern and eastern Europe. Like the American eclipse of 2017, the entire Sun would be obscured by the Moon, meaning that one could look directly in the direction of the Sun, safely, not to see the Sun or the eclipse itself, but to try to see what's behind it. The light of stars passing by the Sun itself on its way to Earth, which are normally obscured by the Sun's dangerous glow. If Einstein's theory was correct, the light should be bent ever so slightly as it comes close to the Sun, and here on Earth we would be able to observe that the location of the stars would be slightly out of place from their known positions. This was the proof that Einstein and the physics community needed. Enter William Wallace Campbell and Erwin Finlay Freundlich of the Berlin Observatory. They traveled to Crimea in an attempt to photograph the eclipse, and the location of the stars visible in the immediate vicinity of the Sun. But there was a problem. You see, the solar eclipse was in August of 1914, and just a few weeks earlier, World War I had begun. Seeing how Germany and Russia were now at war, it was highly suspicious that two scientists from the Berlin Observatory in Germany were found in territory then controlled by the Russian Empire, sporting telescopes and cameras of all things. They were both accused of being German spies. Fortunately, Campbell was born and raised in the United States, which was officially neutral at the time. He was allowed to go with some of his equipment, while the very German Freundlich, whose name ironically translates to friendly, was detained and all of his equipment was seized. Campbell set out alone to try to make the observations, but as luck would have it, it was a cloudy day and no observations could be made. Einstein, still lacking the proof he needed, published his theory in 1915 anyway. But Campbell made another attempt to observe an eclipse in June of 1918, while in Washington State in the United States. However, his best equipment had been seized and never returned by the Russians in 1914, and Campbell's improvised setup was unable to gather the necessary proof. The eclipse of 1918 was the last total solar eclipse seen over the continental United States, until the eclipse of 2017, that is. However, hope was not lost. Enter Frank Watson Dyson and Arthur Eddington, English astronomers, and the eclipse of May 1919. Dyson and Eddington traveled to the island of Principe off the coast of Africa, and here they were finally able to observe and photograph the Sun and the surrounding stars. The location of the stars of the constellation Taurus were found to be slightly out of place when compared to their known location. These observations were also made during the 1919 eclipse by Andrew Claude de la Cheroy, Crommelin, and Charles Davidson in a separate expedition to Sobral, Brazil. Finally, there was the proof that light can be bent in a strong gravitational field. And should anyone be up to the challenge and take the proper safety precautions to be able to observe the Sun during an eclipse, similar observations can be made during the upcoming American eclipse. Thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content. Also, please visit us at our website, www.mechanical-y.com.